In this video, I will show how to use MATLAB to plot data in segments, and each segment is uniform in size. First, I will show a very plain way, but it's straightforward way to do this job. By plain and straightforward, I mean we do not apply any logic iteration to access data index, so we do every segment manually. On line 3, we access our data. So this follows the same rule as what Python does. It's similar to Python syntax. So this is the data file A here, we reference here. And making this column here means the full range of the data column. And number 1 means the index of the first column. Here you can see this is the first column, so we are pulling out all of the left, also the first column of the data, and making it to be the x-axis. It's user defined whether you make it to be x-axis or y-axis, and then we put this y-axis here, also the full column and the second column, so on the right hand side. This is y-axis, and these are the full range of x and y. Next, we make the segments of x and y-axis. This can be done simply by giving the index number for the column. So you can see for the full range, that is just a column, and for the segments, we give MATLAB the number. And one difference between MATLAB and Python is the indexing rule. MATLAB index from number 1. So here for the first 2000 data points, I give 1 to 2000 here. Accordingly, y needs to be the same length, also 1 to 2000. And for segment number 2, we do here uniformly. So from 2000 to 4000, and then until segment number 4. Next, we plot the figure both in full range and the segments. So first in full range, we put the figure in figure 1. Simply apply figure function here and give figure 1 number. And next, using plot function, putting x-axis to be the first parameter, y full to be the second parameter, and specify the format of the points. Here we make it as a dot. Next, we specify x label and y label. So here x is, you give the name of the axis, here voltage, and you can define the font size, here 10, and font weight, bold, and also the color to be black. So these are very straightforward, that the parameter of both x and y label can be found in the MATLAB documentation. If you search here on the right hand, upper right, if you x label, then you will access the instruction of this function. Moving on, we come to plot each segment of data. So we create a figure number 2. The only difference here between figure 1 and 2 is we have subplot in figure 2. So in subplot, there are 3 parameters. It happens to be 3 to 1, but 3 simply mean that in the subplot, we will have 3 lines of figure and 2 columns, and the last number means the figure index. So I will run this code and you will see how this looks like. Now you see on the plotted figure, we have 1, 2, 3, 4. So subplot simply means you have specified number of plots in your figure. You see here figure number 2, and here 3. Oh, I created 3 lines. I should just created 2 lines. So if I change this to be 2, as I only have 2 figures, 2 plots here, 4 plots here, sorry. So 2 is enough, 2 lines. If you have 6 plots, for example, you have another 2 on the bottom, then 3, 2, 1 will work. Here we put to be 2, 2, 1. I change all this to be 2, 2, and 2, 2. And this is also 2, 2. Okay, and we run again. Okay, now you see 2 by 2 subplot figure, and this is a 4 range figure plotted by this code. Okay, so here you may ask, it seems to be very repetitive in the code. Should we use a iteration to do the same job repetitively? The answer is obviously yes. So this is a piece of code doing the same job, but the code itself is much shorter. So we do not need to do the repetitive job. The data loading and the declaration of X and Y column is the same, and the same method to plot the full data range. So the difference is only the segmentation part. Let's see. Here we give a variable 2000 as user defined the length of the data, and the same thing to create a figure that contains the subplot, and we use a for loop that can do the job. As I explained previously, one difference between Python and MATLAB is the indexing rule. So for Python, in my last video, you will see that Python index by default from 0. And for loop, in Python, you do not need to specify the index, the iteration number from and to. You just specify the indexing up to a certain number. But for MATLAB, we need to make the indexing from the beginning number to the end number here, as we will iterate for 4 times to plot 4 figures. So we will start from 1 to 2. Now let's move on. You can imagine that it will be iterate a code for 4 times to plot 4 plots. The very important part here is to access the indexing number correctly. We will keep this a moment later and assume that we got it, and then we move forward. It's very simple. We get the subplot. The iteration number is the k from 1 to 4. So each figure will generate it at the specified 1 to 4 position here. So let's first run this code. So you can see here, here I move it larger. So number 1, 2, 3, 4. Let's move it. This is the 4 range, this figure 1. Okay, so this is subplot, and this k means 1, 2, 3, 4. This is index here. And so when we plot, we use the same plot function, x-axis, y-axis, and we give a line style here. So these are the parameters that you can find if you reference to MATLAB documentation. So you get, for example, a plot, and then you will see the documentation of this. So, and then marker square, because I put this format specification, so this plot seems to be obviously is thicker than the previous one. Previous one, I only put X and Y here without any other formatting, so it will just by default giving the thin line. And if we zoom in here, we zoom in. Oh, zoom in. You can see for this data, we not only give the points to be the square, but also we have the line specified by line style. And next we give X label. X label, this is the same as here, the formatting. And next, to differentiate each plot, we gave a title of each subplot. So the title obviously needs to be moving forward as we iterate forward. Here we can iterate on the plot title by using string concatenate function. Here you can see string concatenate, and we take two parameters for this function. The first parameter sec, and we want to have the iteration number k to append after this segment sec string. One difference between MATLAB and Python is in MATLAB you need to convert the iteration number k to string. You won't just take a k as the parameter. So here, to convert k to string, there is a function called num to string, and we put k here, and this will get four title for 4 plots as we run in this loop. Now we get back to the indexing part. So X indexing and Y indexing are the same. So here, segment, this number is user defined, and you can consider or imagine it to be just a multiplier. So this won't affect your logic to access the correct indexing. And the difference between MATLAB and Python, I put it here on the right hand. You can see if this is the data here, two columns, and if it's Python, the first line will be number 0, and then the last one is number 9, and the total length of the data is 10. But for MATLAB, it starts from number 1 and it ends at 10. In Python, you access this data by indexing, just taking the iteration number k, for example. So when k equal, and it starts from k 0. When k equals to 0, you will have 0 to 10, and then 10 to 20 when k equals to 1. But for MATLAB, as this k starts from 1, we want to have 1, 11, 21, 31. So we add 1 to k, but meanwhile we need to minus k to get this number. Okay, so that gives us this indexing for X segment and Y segment respectively here. And then we run this code eventually. You can see there are 4 plots coming out. And let's get this back to 2. And we run it again. Okay, perhaps in this video you will notice that MATLAB doesn't require you to specify DPI value, meaning the figure resolution value in the code. So this will give you very high resolution interaction with the data. As you can see, you can zoom in the plot to very, very small area and to examine each data point. So this is an advantage of MATLAB, and that's also a reason that I highly recommend you to use MATLAB to do data analysis and data plotting as well. Okay, hopefully this video is helpful to you. Thank you very much for watching.